Hey guys, welcome to 9.2. We are going to learn about the different types of reactions that occur. And there's 5 basic types of reactions: synthesis, decomposition, single replacement, double replacement, and everyone's favorite, combustion. Combustion reactions are always everyone's favorite reaction because who doesn't love a little organic compound reacting with oxygen in the air to produce some serious carbon dioxide, water, and heat? Am I right? No? You don't understand what I'm saying? Well, in simple terms, combustion reactions are kablooey reactions, the ones that blow up and everyone's like, yay! Combustion reactions can lead to things like this. So for the rest of this video, anytime I say combustion, I'm going to show that clip. Number 1 is the synthesis reaction. A synthesis reaction is a reaction where you have multiple reactants and you produce a single product, just one product. So, for example, here I have one reactant, 2 reactants. So you see I have multiple reactants here, and then I lead to one product, okay? So here's another example. Here's hydrogen gas and oxygen gas, and when they react, these are 2 reactants. You can see here's one reactant and here's the other one. It produces something that we all use every day, and that's water, dihydrogen monoxide. So we see we have 2 multiple reactants, but we end up with just one product. So one product, single product, is really our key to remembering what a synthesis reaction is. Synthesis means to form, to make, to create. Decomposition reactions, essentially they are the absolute reverse reaction of synthesis. So here we have a single reactant, and we're going to produce a bunch of products. So here we have our single reactant, and we're producing 2 products. Now, you don't always produce 2 products. You can produce like 3, 4, 5 products. It doesn't matter. But you have to have more than one product being produced. So here's an example. This is one of my favorite reactions in the world. It's called the decomposition of sodium bicarbonate, right? Doesn't that sound fun? But it's also called the gummy bear sacrifice reaction, because if you take some gummy bear and you put it in some potassium bicarbonate and you heat that sucker up, man, it explodes. It's so cool. The gummy bear screams and it's like, wah, and it dies, and it's really cool. Anyway, this is the reaction that occurs. Potassium bicarbonate decomposes into just potassium, JK. It decomposes into potassium carbonate, carbon dioxide, and water. So how do you know if it's a decomposition reaction? It's if you have a single reactant. It's the absolute opposite of synthesis. So single reactant is decomp because you're breaking it down, and then synthesis is a single product because you're making something new. So here's some on your owns. I'm going to try and stump you with these. We'll see if you get them right. See how well you were listening to me. On your own, there's 2 problems. One of them is synthesis and one of them is decomposition. So look at them and try to figure it out. And then I will tell you whether or not you're right or wrong in class, but you have to try them. Okay, here's another pair of reactions that are similar. It's called single replacement and double replacement. And the title I like to give to these 2 reactions is Everybody's Cheating on Everybody. Why do I give that title? Well, a single replacement is essentially, let me get my pen, one element steals from another compound. And it's really one single element steals from another compound. Okay, so look at our little picture here. This is a compound. How do I know it's a compound? Because it's got 2 or more elements bonded together. So this is our compound. Okay? And our compound exists of a boy and a girl. Okay? And so the first element in the compound I always pretend is the guy. Okay? And then the second element I pretend is the girl. And then there's a single element. Okay? And the single element is always a guy. And so here's what's happening. Red and blue are going along their merry way, you know, having fun, whatever. And then this new guy comes into town, yellow, and he's like, man, that blue girl is square. I want to, get with her. And so he kind of screws red guy over, and red guy gets pushed to the curb. And guess what yellow guy does? Yellow guy gets with the square, and he's like, this is awesome. She's so cool and blue. And yeah, it's awesome. So the single element, this guy replaces the red element. Now the red guy is on his own, crying in his Kool-Aid. So how does this look in reality? Well, here's a example. Here's zinc. Okay, zinc is the guy. And then it's mixed with hydrogen chloride. Again, H is the guy. The first element's always the guy. Then what happens is zinc's like, hey, H, I'm going to take chlorine from you. And so zinc and chlorine get together, and poor H is now all on his own, and he doesn't know what to do, and he's really sad. So what is our key? Our key to this one is if you see a single element on one side and you see a different single element on the other side, it means they swap places. So if you see one single element on the left and a different single element on the right, you know it's a single replacement reaction. Okay, what about double replacement? Double replacement is things just get weird, man. Things get weird. What happens is you have a couple, a compound, and then you have another couple or another compound, and the first element in both of those compounds just decide, hey, I'm bored in my current relationship, and so they both end up switching partners. Okay, so the way I show this, let me give you an example, is here's sodium chloride, okay, NaCl, and then that's the first relationship, okay, and the next one is AgNO3. Ag is our first element, NO3 is one, think of it as being one thing, okay, one, that's the girl. And what happens is, I always draw it like this, Na is going to take silver's place, so it'll be NaNO3. Do you see how Na is now with NO3? And then what happens after that is silver decides that he wants to get with chlorine. So it's silver chloride. So as long as you see the first two elements literally swapping places to make the products, then you know it's a double replacement. That means we have basically two things are replacing. So the key to this one, oh, I didn't even write the definition. What am I doing, y'all? Okay, double replacement reaction, here's your definition. Two ions or two elements, okay, switch compounds forming two new compounds. So my key is, do you see two compounds at the beginning? And only two. You can't see 3 or 4. You have to see 2. And do you see two compounds at the end? If you see two compounds at the beginning and two compounds at the end, it's going to be a double replacement reaction, okay? All right, so again, we have on your own. Let's see if I can stump you with these problems. Go ahead and try these two problems on your own. One of them is going to be double replacement. One of them is going to be single replacement. So label which one right here, which one is which, and then pause the video to do that, and then start it again, and we'll talk about our very last reaction, which is everyone's favorite, combustion. Okay, now that you're back from doing your on your own problems, let me define combustion reactions. Anything that reacts with oxygen. If you have something reacting with oxygen, it's always going to produce heat, and most of the time, in our class, it'll be all of the time, you produce CO2 and water. Other classes, like when you get to college chemistry or AP chemistry or pre-AP, you'll learn that carbon dioxide and water aren't always produced, but in our class, we're going to pretend that anytime you have a combustion reaction, you produce carbon dioxide and water every single time, okay? So in one of my demos I'm going to be doing here pretty soon, I'm going to take sugar, C6H12O6, okay, and I heat it up and I expose it to air. And when you expose it to air, guess what's in air? Oxygen. And you need oxygen to light anything on fire, because anything that you light on fire is considered a combustion reaction. So anytime you light anything on fire, for example, when I light sugar on fire, you will see gas produced. That's always carbon dioxide gas. And then there'll actually be water vapor and sometimes liquid water that's produced as a product. So that's combustion reactions for you. And that is it for our 5 types of reactions. Keep living the chemistry life.